In this lesson, we will discuss chapter number 3, integration exercise 3.3, question number 8, part A. And the question we have integral of dx divided by x square minus a square. And see, one more time I will explain to you that this exercise is based on the substitute method. So we have to substitute. Suppose we say x is equal to a secant of theta. Right, so a is the constant and secant theta is the variable or the trigonometric term. So the question arises, why I have taken secant theta here, not sine theta, not cos theta, right? So there is a reason. I will explain to you here. See, the formula we have, tangent square theta equal to secant square theta minus 1. See here, this trigonometric function secant square theta, which is variable, it has a positive here, and the variable, sorry, this is the constant. Constant has a negative sign. So this is the only formula in which constant has a negative sign. So this is the constant and it is minus constant, and this is the trigonometric function or a variable. If I will say here, just like suppose sine square theta is equal to 1 minus cos square theta, or cos square theta is equal to 1 minus sine square theta. The rest of the formulas has positive constant. On the other hand, they have negative variable or negative trigonometric term. So this is the formula. That is why we have used secant theta, and this is the constant a. X is equal to a secant theta. So we will take the derivative of this. So it is dx by d theta equal to a secant theta tan theta. So we will separate the variable dx, just cross multiply. It will be equal to a secant theta tan theta and then d theta. Right, so see, this is dx. We have dx in the numerator. So this is the dx, and instead of dx, we can write down a secant theta tan theta. So see here, a secant theta tan theta d theta. And in the denominator, it is, see, x, this x is equal to a secant theta, only the x, right? You do not have to consider the power, only the x. So it will be, instead of x square, we can write down a square secant square theta. See, x square, see, and then we have minus a square. How simple it is, right? So okay, move on. The numerator will remain the same here, which is a secant theta tan theta d theta. In the denominator, we can take a square as a common. So in the parenthesis, we have secant square theta minus 1. I will show you from here. See here, a secant theta tan theta d theta will remain the same in the numerator, while from the denominator, you can take a square as a common. So a square as a common. Right? Okay, now if you will go step by step very carefully, always you will do integration correct. So this is, see, again a square and secant square theta minus 1 equal to tan square theta. Tan square theta, and I have mentioned here as well, tan square theta is equal to secant square theta minus 1. Now what we will do in the next step, a secant theta tan theta, the numerator again will remain the same. In the denominator, this 2 will cancel with this under root, this square will cancel with this. We have only a tan theta. So A will cross A with tan theta. Tan theta, we have integral of secant theta d theta is left, right? So here we know the integration of secant theta. It is natural log of secant theta plus tan theta plus c. And here I will write down c1. I will show you at the end why I have put c1. This is not your answer. This is the integration, but this is not your answer. Why? See here that this is the secant theta. This is fine. Here we have assumed secant theta. A secant theta is equal to x. But here we have tan theta as well. So we have to convert this tan theta into secant theta. What we will do natural log of x secant theta. I will show you from here. Secant theta is equal to x over a. See from this here x over a. So I will write down x over a. But for tan theta, I will write down here secant square theta minus 1. Again, this is the important point. Why I have put secant square theta minus 1? I will do this in the next slide so it will be more clear. What I said, natural log of x plus a. This is the value of secant theta. But for secant tan theta, I have put secant square theta minus 1. Here see, formula is tangent square theta is equal to secant square theta minus 1, right? But we have here tan theta. We do not have tangent square. We have tan. So we will take this is very important point, square root, right? So this will cancel this. Tan theta is equal to secant square theta minus 1. That is why instead of this tan theta, I have put secant square theta minus 1 under root. I hope this point is clear and this is very important point, right? I will write down C1 here. Okay, now natural log of x plus a and then secant square. So secant, the value of secant is x over a. It will be x square over a square minus 1 minus plus c1. See, it is in fraction. So we will take the LCM, which is equal to x square minus a square divided by a square c1. Again, natural log of x over a plus numerator will remain the same, which is x square minus a square divided by this square will cancel this square root, only a is here, and then plus c1. Now see, again it is fraction, so again we will take the LCM. It will be x plus x square minus a square divided by a plus c1. Now from here we will use the formula, which is equal to natural log of, we will take numerator separate and denominator separate, this minus natural log of a plus c1. See, now I will show you why I have taken c1. This is natural log of a. Again, this is constant. So we will combine this and we will make, I will write down here. So the answer will be natural log of x plus x square minus a square plus c. This is the important point. That is why I have put c1 here, right? At the end, we will make the natural log of the numerator and then separate for the denominator, and it is constant. So combining these two, we will get one constant of integration, which is called only c, right? If still you have any question, please without any hesitation, you can ask me, and thanks for watching.